All right, so lesson 4.5, equations of parallel and perpendicular lines. So we have been looking at both parallel lines and perpendicular lines and what we noticed about their slopes, how they are the same and how they're different. How can you find the equation of a line that is parallel or perpendicular to a given line? So we've done one example of what we're doing today in each of the previous lessons, but we're going to go back and do this again because I know there was some confusion. So hopefully we're going to be going through it step by step and make it a little bit more clear for you and easier to understand. So your first slide is a drawing slide. And you guys are going to draw a pair of parallel lines and a pair of perpendicular lines. So on the left, side one, draw me a pair of parallel lines. What does that look like? And then on the right, draw me a pair of perpendicular lines. What does that look like? So you can take notes after the fact. You don't have to do it right now. I'd rather you just participate and pay attention. I have lots of responses. Here we go. We have a pair of parallel lines and what looks like they are perpendicular lines. It's another example. Oh, I like these lines. They have little arrows at the end, which means that they are in fact lines and not line segments. That's really good. Okay. So we're seeing typically the same thing. Someone uses some different colors. This person's adding in their arrows right now. Very good. Yeah, when you do have lines, you do want to put the arrows there, and that's what distinguishes a line segment from a line or even a ray. So if just one side has an arrow, that's a ray. If both sides have an arrow, it's a line. If neither side has an arrow, it is a line segment. Lots of color going on in this one. I like that. I'm looking for something on the perpendicular side that maybe somebody would add in to really show that they are perpendicular. How would you show that? What could you add in on the right-hand side in the number 2 section for perpendicular lines? Because there's something about perpendicular lines that's always true. We talked about this yesterday. Yes, yesterday. They meet at what angle, and how would you show that that angle is there all the way around? Aha, here we go. That's what I was looking for. See that little box? That is the 90-degree angle symbol. That is a right angle. And if that's a right angle, then, well, the rest of these are also right angles. They're all right angles all the way around. Okay, perfect. Okay, so we're going to move on to slide 3. And so this is just an example worked out. All right, I'm going to read through it with you. And this is what we did Monday. I want to say Monday. Yeah, Monday when we did our lesson on proving parallel lines. So this example, the line parallel to y equals 5x plus 1 that passes through the point -1, 2. We want to figure out the equation of that line. We know that parallel lines have equal slopes, the same value for the slope. And if you look at the equation, the slope of the required line is 5, because that's what we're given, that we have a 5 here in front of the x, which means the slope of this line is 5. So our new line is going to have a slope of 5 as well. And if we know the slope and we have a point, then we can use point slope form, which is right here. This comes from the slope formula. You can rearrange the slope formula to get this equation. Y minus y1 equals m times x minus x1. And then we just substitute in the slope, the x value, and the y value. The x coordinate and the y coordinate and the slope. The slope is 5. 5 goes here. The x coordinate is -1. It goes here. You have to be careful when you have subtraction and you're plugging in a negative. Okay, don't accidentally just leave one out because you already see it there. And then the y value is 2. So once we have it substituted in, then we can simplify it. X minus -1 is the same as x plus +1. And if you use the distributive property, 5 times x and 5 times 1. And then from this point here, we want to solve this equation by combining like terms. We're going to add 2 to the left and add 2 to the right. So y is equal to 5x plus 7. And that's the equation of the line. That is parallel to y equals 5x plus 1. That also passes through the point -1, 2. Okay, so we're going to do a problem together now, step by step. So this is the first one. It's an interactive slide for you. This is B, the line parallel to. Here's our equation, y equals -3x plus 4. That passes through the point 9, -6. And you're going to type 2 things for me. You're going to type what would go in the first box. Parallel lines have blank slopes. What word can I put there that would make that a true sentence? Parallel lines have blank slopes. And then the second thing you're going to type for me is, so the slope of the required line is, that's a value. So you're going to give me a word and a number. Parallel lines have blank slopes and then a number. So the slope of the required line is blank. You're going to type for me one word and one number. Parallel lines have blank slopes. And the slope of the required line, the equation we're going to come up with, what will the slope be? What will our value of m be equal to? I have 11 responses so far, so I'm just waiting to get a few more before we talk about what it is. And you don't have to worry about being incorrect if you're not sure. Okay? Because right now I have like all my screens open. So I have our Google Meet. I have the presentation that I'm presenting to you guys. And I also have like a teacher dashboard. So I can see what you're writing. So like I can see like someone wrote like, I don't understand. Parallel lines have parallel slopes. I understand where you're coming from to write parallel there, but that's not exactly the word we want to have here. So I'm going to go ahead and show the responses real quick. Same, and then I don't know. Same works. Another word that would work there is equal slopes, the same slope or equal slopes. So if the parallel lines have to have equal slopes or the same slope, then what would the slope of the required line have? So the slope of the required line is what number? All you have to do is look at this equation. What's the slope of this equation? What's right here in front of the x? So don't forget about the negative. The slope is going to be -3. So I'm just going to show you the next slide. The parallel lines have equal slopes. So you've now been moved forward to the next slide. Or you could also put same, means the same thing, same, equal. So the slope of the required line is -3 because -3 is the coefficient of the x term in that equation. All right, we're going to move on. We're going to take that information because now we know the slope. We also have the point, right? It's giving us the point right here, 9 and -6. And I'm going to use point slope form. Y minus the y coordinate equals the slope times x minus the x coordinate. So what order should I put these values in? I want you to give me 3 numbers. You're going to type out for me 3 numbers in the correct order. So what goes in the first box? Which number? Is it 9, -6, or -3? What goes in this box? Is it 9, -6, or -3? What goes in this box? Is it 9, -6, or -3? What's the correct order to enter in 3 values so that I'm substituting correctly? Somebody had the right answer, they just deleted it. And that was, oh, it's the name underneath. I think it was Natalie. Natalie, you have the right answer. So on this slide, you're only going to type 3 numbers. You don't have to have any words or equations. What's the y value? What's the m value? And what's the x value? Because we're substituting in. We have to take this x coordinate, this y coordinate, and this slope and put them in the right spots. When you're trying to figure out which is the x and which is the y, think about alphabetical order. What letter comes first in the alphabet, x or y? So same thing here. These are in alphabetical order. X, y. The x is 9, the y is -6. So this first value here, the y coordinate, is -6. Okay, I'm going to show some responses. This is pretty organized. Y is -6, m is -3, and x is 9. That's true. That's right. That's the order we're going to put them in. This person wrote it out entirely, which is pretty nice as well. -6, -3, and -9. And they even have all their subtraction signs correct. Okay, so you don't have to worry about changing your answer right now, but I'm going to show you. -6, -3, 9, just like that. Okay, so this next slide, now you're taking the correct substitution of the point slope form and you're going to simplify it. On the left-hand side of the equation, y minus -6 is the same as y plus +6. We add the opposite when we subtract a negative. And that part's done for us. You're going to give me two values, two numbers. What number goes in this box? What number goes in this box? Some of you are writing the equation, that's totally fine. If you want to keep it easier, you can just write two numbers in the order that they would show up, and I'll understand what you're doing. Okay, let's go ahead and show some responses. This box and this box, what values go here? -3. The x is here, so I don't need to write the x twice, but that may just been because you're trying to write it out. Some of you are putting +3. Why would the negative go away? It's still negative, -3. But notice this changed to a plus. So -9 is the same as adding -3, -9. -3, -9. Oh, wait, what did it do? It's 27. Okay. So I didn't even notice. I made this myself and I forgot what I did. So it's taken it, and we had parentheses here. And I should have mentioned this, but I didn't even notice it. And I don't think anybody else really noticed it either. This person did. Noelle noticed. So since the parentheses are now gone, it's actually showing the distributive property. -3 times x is -3. And -3 times, you can think of this as -9. Or you could think of it as 9. It's 27. And the two symbols, negative symbols, or subtraction and negative symbol, turn into -27. +27. +27. Aye. Okay. So they distributed. -3 times x is -3x. And then -3 times -9. The two negatives turn into a positive, +27. Okay, last one, last part of this. We're going to solve for y. y equals, what is the final equation? There's a 6 on the left-hand side we have to get rid of. You can type the final equation for y, or you can just give me the 2 values that go in the boxes. Okay, guys. So we are in the last 10 minutes of class. Let me show you the last slide that we're going to get to today, which is right here. So the last step would be to subtract 6 from the left-hand side and subtract 6 from the right-hand side. 27 minus 6 is 21. So our final equation of the line that passes through the point 9, negative 6, and is parallel to y equals negative 3x plus 4 is y equals negative 3x plus 21. The slopes are the same, but then we had to use the point slope form to substitute in and figure out what the y-intercept would be. It's plus 21. So this is a lesson that we're only halfway through, and I thought it would be like a lot quicker. So we're just going to pause this one. We're not done with this lesson. I don't want to continue it anymore today. We'll do the rest of it next week.